This is a bit of a quick demonstration of this new parachute reefing device that I developed for a particular project. As mentioned on the Rocketry forum, a couple of people have mentioned they like to see a little bit of ground testing, which is difficult to do in its actual application, but I will demonstrate basically what it's about anyway, and you'll get some sort of idea. So basically, we've got the device and a little tab, and basically what the device does is it receives an RF signal from either the ground or the rocket electronics, and it basically tells this device to disconnect, which will unreef the parachute, which I'll explain further. So basically how it works is we turn the device on, and we insert the tab, and we push the lock button, and that's it. The tab is locked. The tab will not be released until the device is commanded to release the tab. Right. Okay, so to demonstrate the device actually working, I will use the tension of an elastic band and connected to the tab, stretched out, and the device is on, and I will send a signal through this laptop, through some software, through an RF transmitter, which is a little bit of power overkill, but for this application, but nevertheless, we'll go in 3, 2, 1, and there you can see the tab. Okay, we've got a 20 kilogram block hanging off the device, which I'm going to release. I'll run in the house and give the signal over the RF. Okay, with this test I'm going to really crank up the load well beyond its maximum recommended. So we've got a crane scale measuring the tension, which is going to be cranked up with a jacking screw manually down this end, and of course we've got our device here that will hopefully hold the tension and let it go on command. So let's see what happens. Okay, we're measuring in newtons and we're cranking the tension. I'm going to run to the inside the house when we've achieved a suitable amount of tension. So approaching 600, and just getting a little bit scared because there's a bit of stretch in this system. All right, 800. Okay, and 900. Okay. All right, 1,000 newtons there. Running into the house, and I'll give a countdown over the two-way. All right, let's go. So I touched on another feature of the device is an internal LDR, which is a light dependent resistor, something that looks a little bit like that. Um, and that's going to be used for separation detection. So basically the principle there is um, the device will be wrapped up in the parachute inside the the um, the the airframe, and upon deployment, everything will unravel and it will be exposed to the light of day, and the LDR will be triggered. So basically, how that works is, it basically just triggers it, and it sends an RF signal off to the main electronics, suggesting there's been a successful separation. To simulate that, I will cover the device with a box like so. I will use a typical little terminal program just to show this. So I'll send a little code to the device, saying that, and it's responded saying with another code saying, "Yep, okay, we're ready to go in terms of triggering the LDR." To simulate a successful separation, I will just lift the box, expose some light, and as I'm lifting the box, I will show the screen on, and I'll lift the box, and there's the code. It sends three codes, basically a triplicate code. The same code three times, just to make sure it gets through, and make sure the electronics knows what's going on. Okay, so just a very brief explanation of what I'm talking about with regards to the whole reefing thing. So this is an example here. This is a much smaller chute that I use for HPR, some HPR. And so what I'm talking about here is banding, putting a band around the chute part way down, and using the device to hold that band together. So rocket reaches apogee, deploys, and basically this part of the chute opens out and effectively acts as a drogue. So you've got your main chute, but your main chute acting as a drogue because it's being clamped here by the device and a bit of cord. So when it's time to actually release the main, it's basically just releasing that band and letting the chute completely open, and there you have a main. Pretty simple stuff, but the trick is in the clamping force and having a device that's capable of holding that force and releasing reliably. So getting back to the project, where this is actually the chute that I'm looking at using for the project, and you can see the device there. So large chute, small device, shouldn't be too much of a burden on the volume and the mass penalty.